Good morning, my dear students. Welcome to Kreatryx channel. Welcome to Unacademy and welcome to Impulse batch. So there was a small technical issue from my side, so we are starting the class a bit late. Okay, before going to start, let me introduce myself. I'm KV Swami. I've done my MTech in Systems and Signal Processing from JNT College of Engineering, Hyderabad, and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching the subject signals and systems and communication throughout the country. I have 12 plus years of teaching experience, and now I'm associated with Unacademy. If you want to purchase any course in Unacademy, you can use the code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions here. The first one is called the Plus subscription and the second one is the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the class in Hindi, and if a student is not comfortable with Hindi, he can take the class in English from his choice of educator. And we have rank improvement batches also. Apart from this, we have one more subscription known as Iconic subscription, in which the student will be under the supervision of a educator known as mentor. So here personal coach is given to the students, study planner is given, study booster sessions are there, personalized test analysis is there, preparatory study material is given to the students, and dedicated doubt clearing instructors are also there in Iconic subscription. Coming to the fee structure. What is the fee structure in Plus subscription and Iconic subscription? If a student is planning for GATE or ESE preparation for 12 months, that is 1 year, it costs around in Plus subscription 27,225 rupees using the code KVS Live. You can use the code KVS Live. And GATE or ESE preparation for 18 months, that is 1.5 year course. So in Plus subscription, it costs around 34,650 rupees using the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months. That is 2 year program. This is ideal for second year students. So this costs around 39,600 rupees only using the code KVS Live. Coming to the next subscription called Iconic subscription. So GATE or ESE preparation in Iconic subscription for 12 months, that is 1 year, it costs around 45,225 rupees using the code KVS Live. GATE or ESE preparation in Iconic subscription for 24 months, that is 2 year program, it costs around 66,600 using the code KVS Live. So whatever may be the course you want to purchase in Unacademy, use the code KVS Live to get maximum discount. Right. Now let's switch back to our topic. Right. So what happened to other? Baraj came, others, Jaitirda. Okay. Fine. So in the last classes, if you observe, we were discussing the topic. What we were discussing is classification of signals. What we were discussing, students? Classification of signals. In which we completed the first part. Even signals and odd signals completed. We have seen many examples in even signals and odd signals, and I'm pretty confident that given any problem from even signals and odd signals, you will be able to solve any question. Good morning, Pathak. You will be able to solve any question from even signals and odd signals. So in the list what I gave, yes, my dear students, come back, all of you. Come back. There was a power cut from my side, so I'm unable to continue. Inconvenience caused is deeply regretted. Yes, we are back, my dear students. Yes. Hi, power cut issues. Okay. Hi, Jaitirda. let's start the class. See, we were discussing the classification of signals, in which I was saying that we completed the even and odd signals, and I'm pretty much sure that given any problem from even signals and odd signals, you're able to solve, right? Hope you have done the homework problem also. The next classification of signals, what we must see is here, energy signals and power signals. So the next topic for our discussion is energy signals and power signals. So this is the topic we have to discuss, very important topic, right? So the next topic for the discussion is energy signals and power signals. So all of you put the heading energy signals. Take the next slide. Energy signals, listen carefully my dear students, and power signals. Here, what is the purpose of finding the energy of a signal? Okay, what do you mean by a energy signal and what do you mean by a power signal here? So before going to discuss what is energy signal and power signal, I want to discuss a small concept known as the size of a signal. Size of a signal. If anybody asks you how to find out the size of a signal, if anybody asks you how to find out the size of a signal, see, if anybody asks you what is the amplitude of a signal at any point, yes, we can say. But if they ask you what is the size of a signal, forget about the size of a signal for the time. If anybody asks you what is the size of a person, suppose if any person is there, you want to measure his size. How a person can measure his size? Now some people will say that I'm having some height h, I'm having 6 feet, so my size is more. Some people will say that I'm more fat. If you count my waist, okay, my waist size is more, so my size is more, right? Generally we can assume the size of a person to be height or waist, but you should not take the height or waist into consideration for measuring the size of a person. If you want to measure the size of a person, any person, male or female, they can be considered as a cylinder. Any person can be considered as a cylinder having some height h and radius r. Both must be taken into consideration, height and waist, so that the best approximate for measuring the size of a person is its volume given by pi r square h. Pi r square h can be given as the approximate for measuring the size of a person. In the same way, how you are going to find out the size of a signal? Now if you observe, signals will be having different amplitudes varying with the time. Signal means what? They will be having different amplitudes varying with the time. We cannot say the amplitude as the size of a signal, and we cannot say the duration as the size of a signal. So if amplitude is more, size is more. If the duration is more, size is more, we cannot say. So by taking both amplitude and time into consideration, we can say that we can take one approximate area as the size of a signal. What is this one? This is nothing but area. Area under the signal can be taken as a measure for size of a signal. But if you observe, some signals will have the positive excursion and negative excursion equal and opposite, so that area becomes 0. Area becomes 0. So area cannot be taken as the measure for size of a signal. Then how to avoid this problem? Instead of taking area under x of t, take area, integration means area, under x square of t. Area under x square of t, which is always positive. So this is nothing but your size of a signal. if you have a signal x of t, you can use this expression to find out the size of a signal, area under x square of t. Again, we have seen signals may be real or they may be complex. So in order to avoid this ambiguity, what we are going to do is, instead of taking area under x square of t, take area under magnitude of x of t whole square. So which takes care of real signals as well as complex signals also. Real signals as well as complex signals also. Again, I am repeating, my dear students, here the topic for today's discussion is energy signals and power signals. So energy signal or power signal, they are related to the size of a signal. Energy or power signal, they are related to the size of a signal. Now, size of a signal, how to measure means, for a signal x of t, even it may be a real signal or it may be a complex signal, use this expression to find out the size of a signal. Use this expression to find out the size of a signal. In other terms, we'll call it by the name energy. Energy. Right? And observe here, my dear students, what is the expression I gave you? Integral minus infinite magnitude of x of t whole square dt. This is the expression to find out the energy. See, if you want this integral to converge, listen carefully. Again, I'll give the total explanation. Don't worry, we'll solve every problem. If I want to calculate the energy or the size of some signal x of t, this must result in a finite value. This integral must result in a finite value. Finite value means value lying between 0 and infinite. And this particular integral will converge. Converge means if you calculate the value of this integral, it will come out to be a finite value when its amplitude becomes infinite. When its amplitudes become 0 as t tends to plus or minus infinite. Means if the signal is like this, or if the signal is like this, so we'll get a finite value of this integral. Otherwise, we won't get the finite value of this integral. Now, if my signal is like this, yes, I can find out the size by using this expression. Or if my signal is like this, as in the second case, so I can find out the size using this expression. Because if I substitute the signal expression in this integral, definitely I will get a finite value. You can verify. Suppose if I have e power minus t u of t, you substitute in this one and see whether you are going to get a finite value or not, which is nothing but your size. Definitely you will get a finite value. What happens if my signal is like this? What happens if my signal is like this? Means its amplitude is not becoming, this is a constant signal, DC signal, its amplitude is not becoming 0 as t is tending to plus infinite or minus infinite. In such cases, see, suppose if you're having these kind of signals, in such, if you're trying to find out the size of the signals, this constant kind of signals, you'll get infinite. You get infinite means this integral, what I said, in order for this integral to converge, it must result in a finite value, but infinite is not a finite value. So for these kind of constant signals, or if you have any oscillatory motion like this in the signal, if you're going to find out the size of the signal using the first expression, what I mentioned, you are going to get this as infinite. If you have any doubt, try to substitute. What happens if x of t is equal to 1? My dear students, if x of t is equal to 1, integral minus infinite 1 dt, which is nothing but something infinite you will get. Right? Means this integral is not converging. Then how to measure the size of these kind of signals? For measuring the size of these kind of signals, we'll go for time average of energy. Time average of energy, which is nothing but average power, we call average time average of energy, average power. So given by this expression, limit t tends to infinite, some 1 by 2t integral minus t to t magnitude of x of t whole square dt. This is the expression used to find out the average power, or this expression is used to find out the size of these kind of signals. These kind of signals. So remember, if anybody asks you in signals, energy and power means they are used to find out the size of a signal. They are used to find out the size of a signal, right? Hope this is clear for all of you. Now I can give you the summary like this. After this, if you don't understand, let me tell you, if you don't understand what I have written in the first two slides, no problem, no problem. Look here, signals, the next classification of signals is nothing but, listen carefully from this slide. The next classification of signals is energy signals, power signals. Means what is the purpose of finding energy or power? To measure the size of a signal. Size of a signal. Now energy is denoted by E infinite. Remember my dear students, energy is denoted by E infinite. Power is denoted by P average. P average. So what are the expressions for finding the energy? Energy, if you want to find out, limit t tends to infinite, integral minus t to t magnitude of x of t whole square dt. This is the expression to find out the energy of a continuous time signal. Observe here, energy means what I told you. Energy means area under square of the signal. Area under square of the signal. The signal may be real or complex. So magnitude of x of t whole square. What I have written here, right? Now if you want to find out energy of a, we have one more kind of signal. No, what is that? Discrete time signal. So if you want to find out energy of a discrete time signal, here integral k means here summation will come, minus n to n magnitude of x of n whole square, right? So average power, coming to average power of a continuous time signal is given like this. You have to remember these expressions, minus t to t. Why we are going to find out the average power? Means generally energy or power, they are used to measure the size of a signal. For some signals, if you are going to measure the size using the first expression, that is this one, this integral will not converge. So we cannot measure the size of those signals like constant, some oscillate periodic signals. So for measuring the size of those constant signals or periodic signals whose amplitude will not become zero as time approaches infinite, you can use the average power expression. So for discrete, you can use this expression. Right? This average power expression can also be written like this also, my dear students. Both the expressions are same. And the average power expressions, what I have written here, this expression and this expression, they are for aperiodic signals. Aperiodic signals. Aperiodic signals means signals which are not periodic. So for periodic signals, this limit will not come. For periodic signals, this limit will not come. Why limit will not come? We'll discuss in periodic signals. Okay. If you solve 2 or 3 problems, you'll get confidence. So again, I'm repeating. First of all, we started our journey like this: energy signals and power signals. So energy signal or power, energy and power for a signal we calculate to measure the size. Energy and power we calculate for a signal to measure the size of a signal. So size of a signal means, example I told you, size of a person. So we cannot say height as the size, we cannot say the waist as the size, but taking both into consideration, we can say volume as the size of a person. In the same way, our signals will also be having different amplitudes varying with the time. We cannot say the amplitude as the size, or we cannot say the duration in which the signal is existing as the size. But taking both into consideration, we can say that area is the size of a signal. Area. But what happens if you are going to take the area as the size of a signal? For some signals will have positive excursion and negative excursion same, so that area becomes 0. But remember, size cannot be 0. So in order to avoid this problem, what we are going to do is, instead of taking area under x of t, take area under x square of t. Area under x square of t, which is always positive. Okay, this expression, again here signal may be real or complex. So magnitude of x of t whole square. So this is nothing but your energy expression. Observe, this is what your energy expression we obtained here. Right? Again, one more problem will come. If you are going to measure the size of some signals using this expression, like constant signal or the signals having periodic motion, so what will happen? You know, this integral will not converge, means this will lead to infinite. So infinite means what? Size is a finite value. Then how to measure the size of these kind of signals? Suppose ut is there, ut is there. If you are going to substitute the expression for ut in this one, you will get it as infinite. Infinite. In which case, what will happen? So we cannot measure the size of ut using this expression. So there must be another expression. So that is nothing but time average of energy. Time average of energy, which we call by the name average power. Average power. Right? And I have given the expressions also. Expressions. Next, let me give you some points that a signal is said to be, very interesting point, energy signals and power signals. A signal is said to be energy signal if its energy results in a finite value. A signal is said to be energy signal if its energy results in a finite value, that is 0 less than E infinite less than infinite. First point to be noted, my dear students. Second point, a signal is said to be power signal. Power signal if its average power results in a finite value. Finite value, that is 0 less than P average less than infinite. Third point, a signal can be energy signal. A signal can be energy signal or power signal, but cannot be both. Means you can find out the size of a signal using the first expression or the second expression. A signal can be energy signal or power signal, but cannot be both. Very important point. But cannot be both. but cannot be both. If you look at one or two problems, everything will come, right? So the point what you have to remember is energy and power, they are used to measure the size of a signal and their respective expression. Energy is nothing but area under square of the signal, and power is nothing but time average of energy. Right. Sometimes what happens, they'll give some signal and they'll ask, say that find out the mean square value, average power, or mean square value, also it is known as mean square value. Mean square value also they'll say sometimes. Mean square value or average power means same. Fine. Observe here. You are given a signal like this. Xt is equal to e power minus 2t u of t. First problem. We are going to solve many problems and you will get perfection like anything. X of t is equal to e power minus 2t u of t, and we are asked to find out whether this signal is energy signal or power signal. All of you concentrate. X of t, a signal is given and we are asked to find out whether this is energy signal or power signal. My dear students, always remember, before going to calculate whether the signal is energy signal or power signal, we must be in a position to draw the shape of the signal. Whatever may be the problem, first of all, we must be in a position to draw the shape of the signal. Now, how you are going to draw the shape of the signal? After that, we can calculate, because we have ready-made expressions. No, we can calculate. That is not a big issue. First of all, we must draw the signal. Here, x of t involves multiplication of two signals, because this kind of signal shape we haven't seen till now. So, first signal is what? E power minus 2t. Another signal is u of t, right? So, how to draw e power minus 2t? How to draw exponential signal? It is known as, name is exponential signal. How to draw? If you don't know how to draw, very simple. Give different values of t. Give different values of t. What happens if I substitute t is equal to 0? 1. What happens if I substitute t is equal to some 1? I'll get e power minus 2, which is a value less than 1. What happens if I substitute the value of t to be minus 1? I'll get e square, which is a value greater than 1. So if you join all the points, we are going to get the signal like this, e power minus 2t. And u of t. U of t we are very much familiar, our friend coming from the initial days. So u of t is a signal like this, right? Now, what is done between these two signals? Multiplication. So multiplication of signals is nothing but multiplying at common points, right? So common portion is what? Again, we came to our normal discussion. Now common portion is what? 0 to infinite, in which this has, the first signal has a different amplitude, the second signal has unit amplitude. Different amplitudes multiplied with unit amplitude is what? Different amplitudes. So that we are going to get the signal like this. Yes, I am able to get the shape of the signal x of t. Fine. It is a decaying exponential. Decaying exponential, right? Generally, students' interest in the class, first day he'll be like this, slowly, gradually interest decreases. Right? Now, by looking at the shape of the signal x of t, can I define x of t like this? So I got the shape. Can I define x of t like this? X of t is nothing but e power minus 2t for t greater than 0 and 0 for t less than 0. Can I define like this? Yes or no? Yes. Why I am not defining at 0? Why I am not defining at 0? Reply in the chat box. Why I am not defining this signal at 0? Jayatida has given the answer also. Why I am not defining this exponential signal at the point t is equal to 0? Why I am not defining at t is equal to 0? Come on. E power minus 2t I said, t greater than 0 and 0 for t less than 0, because this has discontinuity. Discontinuity. Whenever we have discontinuity in the problem, we won't define that at that point. Separately we'll define. Here not required. So this is the definition. Now what we have to find out? Energy we have to find out. So energy expression we have now. So first of all, recollect. Energy is what? Simply area under x square of t. Remember, my dear students, area under x square of t. Signal may be real or complex. So magnitude I am taking, magnitude of x of t whole square. Right? So in our case, look here, E infinite is equal to limit t tends to infinite. Our signal is existing from 0 to infinite, no? So lower limit will become 0, upper limit will become infinite. Magnitude of x of t whole square. X of t is what here? Real. X of t is not complex, but x of t is real. So magnitude square is nothing but square of the signal. E power minus 4t dt. Or E infinite is what? Integral 0 to infinite e power minus 4t dt. Now if you try to simplify this one, E infinite is equal to e power minus 4t by minus 4 between the limits of 0 to infinite, or energy is minus 1 by 4 e power upper limit you substitute, e power minus infinite is 0, lower limit is 1 by 4. So what is the value of energy we are going to get? 1 by 4. 1 by 4 is a finite value, no? 1 by 4 is a finite value. Energy is coming out to be finite value, means what kind of signal is this one? First point, a signal is said to be energy signal if its energy results in a finite value lying between 0 and infinite. So what kind of signal is the given one? Energy signal, power signal? Energy signal. So the given signal is what? Energy signal, my dear students. Energy signal. Energy signal. Oh, then if it is energy signal, let's find out the average power. How to find out the average power? Limit t tends to infinite 1 by 2t integral minus t. Expression is there, no? Just simply I am writing that expression. Nothing I am writing. This one. Now here in this expression, limit t tends to infinite integral minus t to t magnitude of x of t whole square is what? Energy only. Energy only. Or P average is nothing but E infinite. This expression is energy expression by 2t as t tends to infinite. As t tends to infinite. But what is energy we got? 1 by 4 by 2t as t tends to infinite. Something by infinite is how much? 0. Something by infinite is 0. Remember, average power is 0, not here. Average power of energy signal is always 0. Not here, my dear students. Average power of energy signal is always 0. Is always 0. Average power of energy signal is always 0. Not here. Always it is 0. If you want, you can make a note also here that average power of energy signal is always 0. Is always 0. Right? And if you are given this kind of problem in your exam, no need to solve all this also. By looking at the shape only you can say whether this is energy signal or power signal, because in the very first point only I told you. So what is the expression for energy? This is the expression for energy. In order for this integral to converge, or in order for this integral to have a finite value, what I said, amplitude must be 0 as t approaches plus or minus infinite. Means if the signal shape is like this or like this, this is energy signal. By looking at the shape only we can say, right? Or we'll try to generalize. Here I'll try to give one more point. Note, all of you make a note. Note. Size of a signal. If anybody asks you how to measure the size of a signal, means in signal, you said you calculate the energy. So they'll ask you how many expressions you are having for finding the size, means 2 kind of expressions we are having. So you can tell the story. Right? Slowly you get perfection on the topic. So note here, as mod t approaches plus or minus infinite, as mod t approaches infinite means plus or minus infinite, if amplitude of the signal becomes zero, then it is what kind of signal? Energy signal. Oh, fine. Sir, can you tell me one more information? Yes, my dear students, if you are given this kind of problem, e power minus at u of t, where a greater than 0, you need not find out. Directly you can substitute the energy as 1 by 2a. E power minus at u of t means its energy, where a greater than 0, its energy will be 1 upon 2a. Suppose if I give you e power minus 4t u of t. Look here. So we have to analyze. First of all, the shape will be like this. Means yes, I can find out this size of the signal using the energy expression. Yes. And what is its value means? E power minus 8 u of t means a greater than 1 by 2a. 1 by 2a means 1 by 8. 1 by 8. 1 by 8. Right. Sir, energy you are saying you are not putting any units means your wish. Again, go to the starting slides. Look here. Energy, if you want units, look here. Suppose if your signal is a voltage signal, volt square second. If your signal is a current signal, ampere square second. Or sometimes in exam they may put like this also, joule. Now what are the units for power? Look here. By dividing with the time is also there, no? So if your signal is voltage signal, volt square, current signal, ampere square, or they can say watts or something also. Generally they won't specify any units, they specify the value only. Fine. As t tends to plus or minus infinite, plus infinite or minus infinite, if the amplitude becomes 0, then it is an energy signal, right? Suppose if I ask you this one, what kind of signal is this one? E power 2t u of minus t. E power 2t u of minus t if I ask you, my dear students. So what you are going to say? Sir, I cannot say anything until I look at the shape of the signal. Yes, you can draw. Now e power 2t means you know, right? Sir, we haven't discussed e power 2t means no problem here. Give different values of t. What happens if I substitute t is equal to 0, 1? T is equal to 1 means e power 2 is 2.7, e power e square is a value greater than 1, minus 1 a value less than 1. So this kind of shape, e power 2. And what is the other signal? U of minus t. U of minus t will look like this. Now multiplication of signals is nothing but multiplying at common points, so that the resultant signal you are going to get like this. This is your signal x of t. Now as t tends to plus infinite or minus infinite, you observe, if amplitude becomes 0, look here, at t is equal to minus infinite, definitely the amplitude becomes 0. So what kind of signal is this one? First observation is this is also an energy signal. This is also an energy signal. And here also energy, if you want to calculate, it will be 1 by 4, or I can say e power minus at u of t or e power at u of minus t, where a greater than 0 in both the cases will have the energy to be 1 by 2a. Directly you can 1 by 2a. 1 by 2a. Hope everybody is comfortable. And from tomorrow onwards, we'll play with energy signals and power signals. 1 by 2a. By looking at the shape only you can say. Right? Suppose if I give you a question like this. X of n. I am turning my attention from continuous to discrete. Suppose if I give you like this. 1 by 2 whole power n u of n. Now I want to see whether this is energy signal or power signal. And what I said before going to, good morning, before going to observe whether this is energy signal or power signal, always it is better practice, good practice to draw the shape of the signal, because you can analyze with by looking at the shape of the signal. So how you are going to draw? Do you know how to draw the signal? Yes. See, first of all, define this is 1 by 2 whole power n. See, observe here. If you have any difficulty in defining, look here. E power minus 2t u of t is there. No, how we define? It is e power minus 2t. U of t means we'll get the limits from u of t means t greater than 0, and it will be 0 for t less than 0. See, this u of t is for limits. Here u of n is also for limits. Suppose 1 by 2 whole power n. U of n is there now, so n greater than or equal to 0. And 0 for n less than 0. Now I got the definition. Now try to draw the shape of the signal. How to draw the shape of the signal? This is a discrete time signal. So independent variable is n, and we have to substitute only integer values here on the horizontal axis. Now what happens if I substitute n is equal to 0? 1 by 2 whole power 0. 1 by 2 whole power 0 is what? 1. N is equal to 1, you substitute 1 by 2. N is equal to 2, you substitute 1 by 4, and so on. Now I got the shape of the signal. Now can you tell me, by looking at the shape, what kind of signal is this one? Because we made some analysis here as t or n. What kind of signal is this one? As n is approaching infinite, the signal amplitude is becoming 0. So first point is this is an energy signal. First observation is we analyze that this is a energy signal. If it is energy signal, then yes, if it is energy signal, then find out the energy value. How to find out? I gave you the expression. And what is the purpose of finding energy? To measure the size of a signal. So magnitude of x of n whole square. This is the expression. So for discrete time, no, limit n tends to infinite. Signal is existing from what value to what value? 0 to infinite. So 0 to n. Magnitude of x of n whole square. Again, our signal is real here. So magnitude of x of n whole square is nothing but the square of the signal. If I take the square, 1 by 4 whole power n. Or this is limit summation r n is equal to 0 to infinite 1 by 4 whole power n. Now do one thing. Give different values of n. What happens if I substitute n is equal to 0? 1. N is equal to 1. Summation is there, no? 1 plus 1 by 4. I think you know how to open the summation up to infinite. Now if you observe, this is sum to infinite terms in geometric progression. Sum to infinite terms in geometric progression. Sum to infinite terms in geometric progression is what? A upon 1 minus r, where a is the first term and r is the common ratio. A is the first term and r is the common ratio. Common ratio means t2 by t1 or t3 by t2. So a upon 1 minus 1 by 4, which is nothing but 4 by 3, which is a value less than infinite. So energy is coming out to be a finite value. Energy signal verified. Now can you tell me what is the average power? Fatafat, please reply your answer in the chat box. What is the average power for this signal? Already we found out the size of the signal using energy expression. So there is no need for average power, other expression. So it is 0. It is 0. Yes. Not here. Everywhere average power of energy signal is always 0. Okay, average power for energy signal is always 0. Not here. Everywhere always it is 0. Right, variety of questions can be framed on this energy signals and power signals, but just we are in the very basics, right? Fine. Suppose if I give you a signal like this and ask you to find out the energy and power, x of t is equal to some signal I gave, constant 3. X of t is equal to 3 I gave. Find out the energy and power I said. But one thing must strike in your mind before finding the energy and power. First of all, draw the shape. draw the shape, because with the shape only lot of analysis will come. Constant x of t is equal to 3 means like this. Now for a signal to be energy signal, or for measuring the size of a signal using the first expression, which expression? This expression. What is the requirement? When this integral will converge? If we have infinite duration signal, but its amplitude must decay. Amplitude must decrease. See, there is one more signal which satisfies this one. Look here. We can have, if you are talking about finite duration signals, for these kind of signals also this integral will converge. See, finite duration signals will look later, but we are looking at infinite duration signals now. Infinite duration signal, this integral must converge means definitely its amplitude must become 0 as t is becoming infinite. So look here, if you observe what is the shape of the signal, just now I took this one. At t is equal to infinite, do you guarantee that its amplitude becomes 0? No. So first of all analyze, later on we can calculate. So this is not a energy signal. This is not a energy signal. So let's check what kind of signal is this one. X of t. I didn't get you, Jayatida, what you are writing. X of t multiple can we take like this, sir? Okay. So energy E infinite. Energy is denoted by E infinite. Limit t tends to infinite. Integral minus t to t. Magnitude of x of t whole square. This is integral minus infinite 9 dt. Is coming out to be infinite. Which is coming out to be infinite. So energy is coming out to be infinite. See, if in order for this signal to be energy signal, energy must result in a finite value, but this is resulting in a infinite value. So this is not a energy signal. First conclusion. We have to look at, by looking at the shape only we concluded, no, this is not a energy signal. Let's find out the average power. Average power. Limit t tends to infinite. 1 by 2t integral minus t to t magnitude of x of t whole square dt 9 dt. This is, bring this 9 constant outside. Minus t to t dt. This is 9 times integral of dt is t between minus t to t, or it is t between minus t to t. 1 by 2t. Yes, here if you observe, average power is coming out to be a finite value. Average power is coming out to be a finite value. Means what kind of signal is this one? So the given signal is a power signal. Is what kind of signal? Power signal. And for a power signal, what is energy? Energy will be infinite. For a power signal, energy is infinite. For an energy signal, average power will be 0. Yes, you can take J theta. As it is real, as the given signal is real, if you take the conjugate, you will get the same now. Right? So, as we have seen, one note here, what is that? Look here. We can have similar kind of note for the power signals also. Note. That is, as t tends to, or mod t tends to infinite, means plus, or as t tends to plus infinite or minus infinite, if the maximum amplitude of the signal remains constant, then it is a power signal. power signal. Suppose UT, examples are UT. UT, if you observe, its amplitude is constant throughout the interval, so it is a power signal. Sinusoidal, A cos omega naught t. If you observe, maximum amplitude fluctuates between two values, A and minus. Maximum amplitude is remains constant throughout the interval, so it is a power signal. A sin omega naught t. So these are all power signals. Right? And one more thing you have to identify here. Suppose you can have a DC signal or you can have an AC signal, alternating signal. See, DC signal means this one, 3. So in which case average power is DC square. Directly you can write DC square. DC square you can observe. So constant x of t is equal to 3 is a DC signal. What is the average power we got? 9. So for a DC signal, average power is DC whole square, and for AC signal, average power will be RMS square. For AC signal, average power will be RMS square. A cos omega naught is there. We'll try to prove this tomorrow. So what is the average power? This is not a DC signal, this is AC signal, RMS square. RMS is Vm by root 2 whole square, which is nothing but A square by 2. Directly you can write. This is an important one. Fine. So if you have DC signal, suppose instead of this one, if I give you x of t is equal to 5, what is the average power? Means first of all observe the nature of the signal. This is a DC signal. So DC signal means DC square, 25 will be the average power. Directly you can write. Directly you can write. Now, next one. Suppose if I give you a signal like this, Tu of t. Tu of t if I give you and ask you to find out whether this is a energy signal or power signal. First point is what? We have to draw the signal. Tu of t is what signal? Ramp signal. You know, ramp signal. Remember, for this signal, you try to find out energy. It will come out to be infinite, and average power will also come out to be infinite. So we can classify this signal as, we cannot measure the size using the energy expression or power expression. This is neither energy nor power signal. Neither energy nor power signal. Neither energy nor power signal. Here, what is the thumb rule for neither energy nor power signals? By looking at the shape, you can say as mod t approaches infinite. Here for I'm writing for continuous. For discrete n, t will become n if the amplitude of the signal becomes infinite, then it is neither energy nor power signal. Neither energy nor power signal. If the amplitude goes on increasing as t is approaching infinite, then it is neither energy nor power signal. You can classify that signal as neither energy nor power signal. Neither energy nor power signal. Right? So we are in a position that by looking at the shape of the signal, we are able to specify whether the given signal is energy signal or power signal. Now I'll give you some examples. You classify the signals accordingly. X of t is equal to e power minus 2t u of t. X of t is equal to e power 2t u of t. Xt is equal to e power minus 2t u of minus t. X of t is equal to e power 2t u of minus t. Come on, try to draw the shapes of the signals and classify the signals accordingly, whether they are energy signals or power signals or neither energy nor power signals. So first of all, how to draw e power minus 2t, e power minus 2t, e power minus k means it is a decaying exponential. U of t means like this. So multiplication is done. Multiplication of signals, multiplying at common points. The shape of the first signal is this one. Now coming to e power 2t u of t. E power 2t means what is the shape? It will be like this. U of t means like this. Multiplication of signals, multiplying at common points. Fine. So here e power minus 2t u of minus t, right? So e power minus 2t means the shape will be like this. U of minus t means like this. Multiply, the resultant signal shape will look like this. E power 2t u of minus t. E power 2t means like this. U of minus t means like this. Multiply like this. Now can you classify? First of all, first observation is these are all infinite duration signals. So as t is approaching infinite, its amplitude will become 0. This is, I can classify this as energy signal. Now here second one, if you observe, as t is approaching infinite, this value will become infinite. So this is not an energy signal, not a power signal. This is neither energy nor power signal. Now e power minus 2t u of minus t is there. As t is approaching minus infinite, its value is becoming infinite. So this is neither energy nor power signal. Very simple. Now here last one. Here as t is approaching infinite, its value is becoming 0. Means what kind of signal this one? Energy signal. Energy signal. Can we say unbounded signals as neither energy nor power signals? Yes. Okay, hope you are all comfortable, my dear students. Right. Now we'll try to solve one previous gate question. The question is like this. If the energy in the signal f of t is E, then what is the energy in the signal f of 2t, he said. Some options also he gave: E, 2E, E by 2, 4E. Come on, try to answer this one. A, B, C, D. Type your answers in the chat box. Type your answers. If the energy in the signal f of t is E, what is the energy in the signal f of 2t? Don't miss tomorrow's class, my dear students, because we are going to discuss so many problems on energy and power signals. What is your answer? Type your answers. I'm waiting for your answer. A. Vamsi said A. Vamsi answer is A. Means he means to say that energy does not change with scaling. See, what is the relationship between f of t and f of 2t? Means scaling is done, no? So he means to say that energy does not change with the scaling. Okay. Bharat said 4e. Means his answer is D. Energy becomes, if you are scaling by 2, energy will increase by 4 times. Manoj Gajawada is saying that option C is C. So it is E by 2. Okay. Manu is also. See, let's observe. What is the answer? What do you know about energy? Energy is nothing but area under the square of the signal. Yes or no? Energy, to find out, first of all, first point, energy is used to find out the size of a signal, and it is nothing but area under square of the signal. Now, considering this to be a real signal, can I write like this? Do you accept? See, what is it? The information he said is energy in the signal f of t is E. So, based on that information, I arrived at this point. Now, what is asking then? What is the energy in the signal f of 2t? So, f of 2t energy means area under f square of 2t, which we have to calculate. I don't know. I'm assuming this to be E dash. I have to calculate. No, I'm assuming this to be E dash. Now, I'll do one thing. Let 2t is equal to some k. 2 times dt is equal to dk. dt is equal to 1 by 2 dk. Fine. 1 by 2 dk. So E dash is equal to lower limit of t is minus infinite. So lower limit of k is also minus infinite. Upper limit of t is infinite. So upper limit of k is also infinite. F square of 2t is what? K. dt is what? 1 by 2 dk. Whatever may be the variable, either t or k, can I say that this is nothing but energy in the signal f of t? Whatever may be the variable, either t or k, this integral is nothing but E, or E dash is what? E by 2. E dash is E by 2. So option C is right answer. Those who have said option C, you can take 2 marks because this is given under 2 marks. 2 marks question. So Shashi has given the correct answer. Manu has given correct answer. Jaitirtha has given the correct answer. Don't worry. Those who are giving the wrong answer, so many problems we are having. E dash is equal to E by 2. Right? Now we'll do one thing. Let's analyze this problem and we'll see whether we can get some information or not. Observe here. Observe here, my dear students. From the previous gate question, we'll try to analyze that one and we'll see whether we can arrive at any point or not. Observe here. If the energy in the signal f of t is E, what is the energy in the signal f of 2t we got? E by 2. E by 2. Fine. Suppose if I ask you what is the energy in the signal f of 3t? E by 3. E by 3. Right? Hi Abhinav. Suppose if I ask you what is the energy in the signal? See, f of t energy is E. F of 2t means what? E by 2. F of 3t means what? E by 3. Suppose if I ask you, if f of t energy is E, can you tell me what is the energy in the signal f of t plus 1? 2t plus 5. My dear students, if the energy in the signal f of t is E, what is the energy in the signal f of t plus 1? F of t plus 1. In the place of f of t here, substitute f of t plus 1. So f square of t plus 1, t plus 1 is equal to k, dt is equal to dk. Limits will not change, it is same as E. Means what? With shifting, energy will not change. Look here. With shifting, energy will not change. But with scaling, energy changes. With shifting, energy will not change. But with scaling, energy changes. Suppose if I ask you f of minus t plus 1. F of minus t plus 1. F of minus t plus 1. What is the energy? F of t energy is E. What is the energy in f of minus t plus 1? In the place of f of t, substitute f of minus t plus 1. It will be same as, again, E. E. Or in general, you can generalize. Can you generalize like this? If I ask you, if the energy in the signal f of t is E, can you tell me what is the energy in the signal f of alpha t plus beta? Come on, type your answer. If the energy in the signal f of t is E, what is the energy in the signal f of alpha t plus beta? If the energy in the signal f of t is E, what is the energy in the signal f of alpha t plus beta? I'll be now saying, explain scaling one more time, sir. Sir, please look at the example. This is the energy expression, f of t. So f of 2t means what? Replace f of t with f of 2t. 2t is equal to k, 2 times dt is equal to dk. Limits I change, limits will be same. Modify this one. You are wrong. Manu, you are wrong. Baraj is also wrong. JT is also wrong. If the energy in the signal f of t is E, then the energy in the signal f of alpha t plus beta is not E by alpha, but this is E by mod alpha. E by mod alpha. E by mod alpha. Very, very important. Yes, mod alpha will come. You must be very careful. Suppose if I ask you one question. If the energy in the signal f of t is E, can you tell me what is the energy in the signal AF of t? AF of t? AF of t. It is simply A square E. A square E. If the energy in the signal f of t is E, then the energy in signal AF of t is A square E. How I got? Simply substitute in this expression. No rocket science here. Right? Now, based on this, can you analyze? So, energy does not change with what? Suppose energy does not change with what is the first one? First one, energy does not change with shifting. Does energy changes with shifting? No. Does energy changes with shifting? No. Or next, energy does not change with what? Does energy changes with amplitude reversal? See, f of t is E minus f of t is also E. So does not change with amplitude reversal. Still any more points? Time reversal. Time reversal. Does energy change with the time reversal? No. No, it will not change with time reversal also. Right? So energy does not change with time shifting. Here shifting means, let me write to be precise. time shifting, amplitude reversal, time reversal. But energy changes with scaling. My students, energy changes with scaling. So based on today's observation, tomorrow if you are looking at some other observations, we'll update the list. Energy changes with time scaling. Time scaling. This is today's observation, right? Okay. Now, fatafat, can you tell me? Fatafat, can you tell me? Energy in x of n is equal to 2 times 1 by 2 whole power n u of n, and xt is equal to 4 e power minus 2t u of t. Can you tell me what is this value? Fatafat. Everything you have, all the clues you are having. I want the energy in these two signals. First one is the discrete time signal and the other one is continuous time signal. Tell me the answers. Type your answers in the chat box. First one is 16 by 3. Second one, how much? Come on, come on. See, 1 by 2 whole power n u of n. Already we calculated the energy. It came out to be 4 by 3. 2 times 1 by 2 whole power n u of n. So for discrete or continuous, the same thing holds good. A into f of t means a square e. A square means 4 into 4 by 3. 16 by 3. 16 by 3. So second one, e power minus 2t u of t. What is the energy? 1 by 2a. 1 by 4. So 4 e power minus 2t u of t. 16 multiplied with 1 by 4, which is nothing but 4. Hope all of you got the same answers. Okay. So this is just an introduction or basic to energy signals and power signals. Just I'll take 2 minutes to revise what we studied. We started our discussion like this. How to measure the size of a signal? So in order to measure the size of the signal, go for energy and power. And what is the energy means? Area under square of the signal. Signal may be real or complex, so area under magnitude of x of t whole square dt, which we call by the name energy. Energy. So this energy expression works only for some signals where their amplitude becomes infinite when t approaches plus infinite or minus infinite. In other cases, this energy expression, or we cannot find out the size of other signals using this expression. So what are those signals in which we cannot find out the size using this expression? Means some periodic signals like this or a constant DC signals like this, we cannot find out the size of those signals. For them, what to do in order to measure those size? Take time average of energy. Time average of energy. So time average of energy is nothing but average power. This is the expression. This is a expression. Now I gave you the analysis like this. And signals can be energy signals or power signals. Energy is denoted by infinite, power is denoted by P average. Energy signal means, always remember, energy if you calculate, it must result in a finite value. Finite value means value lying between 0 and infinite. Power signal means average power must be a finite value. And a signal cannot be energy signal or power signal. A signal can be energy signal or power signal, but it cannot be both. So energy for a continuous time signal, use this expression, energy for a discrete time signal. Average power for a continuous time signal, which is aperiodic. For periodic signals, what I told you, anyway, we are going to look at the examples tomorrow. This limit will not come. For periodic signals, limit will not come. There is a reason why limit is coming here also, that we'll also discuss. So this is average power for a continuous time aperiodic signal. This is average power for a discrete time aperiodic signal, right? So average power can also be found out using this expression. Tomorrow I'll tell you. Observe here. So the points so we've done some problems. So by looking at the shapes only, we can observe whether this energy signal or power signal. For energy signal, what is the average power? Remember, for energy signal, average power is always 0. And for power signal, energy is always infinite. Energy is always infinite. And we have one more kind of signal. And if you are given DC signal, average power is DC square. AC signal means average power will be RMS square, right? And we have other kind of signal which are neither energy nor power signals, means their amplitude becomes infinite at t is equal to plus infinite or minus infinite. Neither energy, we can classify them as neither energy nor power signals. Alright, we have seen some examples and one previous gate question, and we made analysis. Right, tomorrow we'll solve more examples and we'll have more analysis. But don't miss tomorrow's class. Don't miss the continuity. Today there was a technical issue from my side in the beginning, but tomorrow I think there won't be any problem from my side. So all of you come without fail and come prepared, all of you. Come prepared, all of you, and tomorrow you'll get many homework problems also. So tomorrow and day after tomorrow, we are going to rigorously work on energy signals and power signals so that every concept becomes easy for you. Thank you, my dear students. And before leaving, yes, you can follow me on Unacademy app. I've done some special classes on the Unacademy app, and go and verify unacademy.com at KVs for me. And these are the channels what we are having in Unacademy. This is our channel, Kreatryx, EECAN. This is mechanical channel. This is civil channel, computer science, gate questions, computer science. So if you have any mechanical friends, computer science friends, you please inform them, electrical junction and Apri Express. And finally, thank you, my dear students. And tomorrow we'll meet at the same time and we'll discuss many concepts. But for tomorrow's class, all of you come prepared. Come prepared.